This is lesson 32, Graphing Quadratics. So we're doing another day on this, but today I'm going to show you the shortcut. The reason why I want to show you a shortcut or spend a day doing this is because there's a pattern of what we're doing. So even though you're doing all these little calculations, the graphs are always repetitive and they look the same. So depending on what A is, okay? Because in math and in the world around us, there's a lot of patterns. I don't know if you remember in geometry if they talked about iterations, where there's repetitions in like nature. If you look at sometimes if you see like a seashell, right? If you were to open up the seashell, it kind of like the compartments are the same, and the next compartment's like half bigger, and the next one's half bigger, and the next one's half bigger. And you got this beautiful seashell. You know what I'm talking about? Where like the little compartments get bigger. You follow me so far? Okay. In math, we have patterns as well, and that's just part of the laws of the universe. It's not like we make this up. This is just part of the world around us, is we have patterns, okay? So it's really good as a math student, and as just a human being to see the patterns, because if you see the patterns, then you could trust that they'll work for you, okay? So you're like, okay, this is just part of the laws around us. This is part of the where everything's created. So here are the steps, and you still have to do steps 1 and 2. Okay, but steps 3 through 6 are going to make the problems faster. You're going to do your problems that took like 2 to 3 minutes yesterday. You're going to do them in about a minute, okay, or less once you get good. All right. So here's the problems numbers 1 and 2 from yesterday. Okay, and I'm going to use these as examples today. But let me pull up what I did yesterday for you. Okay, so yesterday I did these problems. I found negative b over 2a, and we figured that out, right? These were exactly the notes from yesterday. And then I did an xy table, and you have to calculate each one, right? The first one, the vertex, you still calculate, and then you have to do all these numbers around it, right? And this is going really fast, right? Because this is just a pressing play from my computer, right? And then we found the roots too, right? But this whole process takes a while. Now, I talked to you yesterday about how there's patterns, right? And if you look at number 2, it's almost done here. After I figured out all these numbers. I'll go a little faster here. Okay. I talked to you about number 2 yesterday, and number 2, doesn't it look just like number 1? Do y'all see that? Okay. If I were to like copy and paste number 2, like the graph, and just flip it, let's watch. I could literally put it over the other one. Okay, so here it is right underneath it. Y'all see that? I'm going to put it right over it, okay? Watch me do this. You're going to see the points line up pretty well, actually, for the most part. Okay, well, you'll see the points are lining up pretty well right there. They're a little different because the size of the boxes are slightly different on numbers 1 and 2. Okay, but do you see how that's the same shape? Can you imagine me flipping it around? Do y'all see that? Yeah or no? Okay, so that's a pattern we have. So I'm going to teach you how to do this the easier way. So watch me do numbers 1 and 2. I'm going to keep the graphs up here because I want you to see. I want you to see what's going on with it, okay? So the first thing I'm going to do is, let me erase all this. You still have to find negative b over 2a on number 1, okay? So that's still normal. So we know from yesterday our negative b over 2a is equal to 4, and I'm going to make an xy table just like yesterday, okay? I'm putting 4 in there, and if I put 4 in, my vertex is at negative 1, okay? So that's the first thing. That's normal. Here's the shortcut now. On your xy table, look at the bottom, we're going to do plus minus 1 and plus minus 2, meaning that if you go left or right 1 from your vertex, you're going to go up or down 1, okay? So we're always looking at relationships to the vertex. We're going to plug in left or right 1 into the first term. So 1 squared is 1, okay? So I'm going to put a 1 down here. That means if I go left or right 1, I'm going to go up 1, okay? So from this point, from my vertex, left 1, up 1, there should be a point here. Is there a point there? Y'all see that? Yeah? Right 1, up 1. Y'all see that? Okay, I need you to get this, okay? Then I'm going to put 2 in. 2 squared is 4. So if I start at my vertex, left or right 2, 1, 2, up, 1, 2, 3, 4. Y'all see that? There should be a point here. Right 2 from the vertex. 1, 2, up, 1, 2, what? 1, 2, 3, 4. Y'all see that? Okay, good. So you would plot the points just like yesterday, and then you graph it, and that's it, okay? Now I did the graph on number 1, and on number 2 it's ready to go. So I'll do it again on number 2. Watch again. Number 2, what do you notice about number 2 before I move on? About A?
Negative.
Negative, right? But what is the number? What's the number in front of it? 1. And you notice how both of them have the same shape, okay? It's negative, so the second one's pointing down, okay? So the first thing you do is you find negative b over 2a. So you go to negative 6, then we figured it out as negative 3. Okay, and when I plug it in, I got 2, right? That's my vertex. Then I did plus or minus 1, plus or minus 2. So up here, plus or minus 1. 1 squared is?
1.
Times negative is?
Negative 1.
-1. So what that's saying is, if I go left or right from my vertex, I'm going to go not positive 1, but negative 1. Left 1, down 1. Right 1, down 1. You all see that? There's a point there. Next one. Left or right 2. 2 squared is?
4.
Times negative sign is?
Negative 4.
Negative 4. So that means if I go left or right 2, I go down 4. Right 2, down 4. Y'all see that?
Yeah.
Okay. And those are where the points are, right? So am I explicitly finding the exact points, like with the coordinates? Am I doing that? Am I doing all these calculations right now? No, I know because the pattern exists, I know that there should be a point here, here, and here, right? That all of these points here exist. Well, that's the vertex. But I know these should all exist because they're in this type of graph. There is a pattern, and we're able to predict these points. Now let's just check to see if I'm correct, okay? Let's say I put in negative 5 into my equation. Negative 5 squared is? Negative 5 squared is? 25. 25 times negative is negative 25. Negative 6 times negative 5 is? Positive 30. Negative 25 plus 30 is? 5. 5 minus 7 is? Negative 2. So if I went negative 5, I should have a point at negative 2. Did I have a point there?
Yeah.
Yeah. You see? So, but did I have to calculate the whole equation every time? No. And this will save you time when you do fractional ones, because you're like, okay, as long as I find the vertex, I could find the actual points without having to explicitly calculate them. Okay, does that make sense, everyone? That's the shortcut. All right, we'll do a few examples here. So before you move on, I want you to talk to your neighbor. 1 cell 2 is about number 1, 2 cell 1 is about number 2. Ready, set, go. Yeah, we should have the same shape on number 3 as we had in number 1 and 2, because A is equal to 1. But we still have to do our first step, which is find our vertex. So how do we find our vertex always? Negative b over 2a. Good. So we're all doing this. You can do this on a separate sheet of paper or on your iPads. That's fine. Okay, b is equal to negative 4, so we got negative 4 over 2 times 1, which is just 2. So this could be 4 over 2, which is all equal to 2. So on our xy table, we have 2 as our vertex point for x. So what would our y be if I put in 2? 1, right? Because 2 squared is 4. Negative 4 times 2 is negative 8. 4 minus 8 is negative 4. Plus 5 is still 1. Okay? So put in 1 here. Okay, so let's plot our vertex. 2, 1. Does our graph open up or down? Up. Good. How do you know it opens up? Okay, good. Alright, so if I go left or right 1 from my vertex, how far up or down do I go? 1, right? Because 1 squared is 1. 1 squared is 1, so we would, oh, excuse me. So we go right 1, up 1. There should be a point here, right? Left 1, up 1. There should be a point here. Okay? What if I go left to right 2? Okay. Okay, good. Turn to your neighbor, discuss it, and then graph it. Show me your graphs. Go. I'll give you about 30 seconds. On this example, you have these points, right? Let's just double check to see if they work. Let's say x is 0, right? We know that this point is 0, 5, right? Would you all agree it's 0, 5? What happens if I put 0 into my equation, okay? 0 squared is 0. Negative 4 times 0 is what? 0. So 0 minus 0 is 0. Plus 5 is 5. Is that correct? Yeah, it is, okay? So you could trust this. You could totally trust what's going on here, okay? Okay, sometimes you're going to have harder problems with a fraction, okay? Don't freak out. Fractions still are okay, okay? So, what's a equal to on number 4? Negative 1. So shouldn't it have the same form as number 3?
Yeah.
Yes or no?
Yeah.
Okay, but it's opening up or down?
Down.
Okay, good. So we still have to start off with our negative b over 2a. Okay, so we got to start off with negative 1 over 2 times negative 1, which is going to be negative 1 over negative 2, which is equal to 1/2. Uh-oh, fractions. Okay, sometimes you have to deal with fractions, okay? Not a big deal. We could get through this. Okay, so our vertex is at 1/2 something, right? Before yesterday, you'd have to deal with a lot of fractions, but today you just have to deal with the vertex, okay? So let's put in 1/2 into our original equation. 1/2 squared is 1/4, but there's a negative sign there. Then we have plus x, which is just 1/2, minus 17 fourths. I know that negative 1/4 minus 17 fourths is negative 18 fourths plus 1/2. I know 1/2 is like saying 2 fourths, okay? So it's like saying negative 16 fourths, which is equal to what? Negative 4. So our vertex is going to be at 1/2, negative 4. Okay, so then I would go to 1/2 negative 4, which is right here, down here. Plot my point. We said it's opening down, right? Yes?
Yeah.
Okay. Here we go. Left or right 1. If I go left or right 1, how far up or down do I go?
1.
1, right? So I'm going to go left 1, down 1. There should be a point here and a point here. What happens if I go left or right 2?
4. Down 4.
Down 4, right? So I go left 2, down 1, 2, 3, 4. There should be a point here and, of course, a point here. That's it. Now look at these points. Are they all perfect, like on the crisscrossing line?
No.
On the lattice points? Are they?
No.
No, they're not. That would have been horrible, right? Imagine doing this problem for homework last night. Would you have done it?
Nope.
No. But now you could do it, right? Because it's like, okay, I could deal with some fractions. I don't have to do all of them. Does that make sense? You following me? Yeah? Okay, let's do one more and then we're done. Okay, what's a equal to here?
2.
2, right? Okay, is it going to look like numbers 1 through 4?
No.
No, it's going to look different, okay? Okay, since it looks different, we got 2x squared plus 12x plus 16. Let's find negative b over 2a. So we got negative 12 over 2 times a, which is 4. So our vertex is at negative 3, right? So we're going to put an xy table again. And we have negative 3 as the x input for our vertex. If I put negative 3 in, what should my output be, my y? Almost. Let's see what we got.
Negative 2.
-2, good. Okay, so if I have -2 there, we're going to go to -3, down 2, -2, right? So I love this method because I could calculate it all out, or I could just go plus or minus 1. So if I go plus or minus 1 here, or left or right 1, how far up or down do I go? Let's put it into the first term. 1 squared is 1 times 2 is 2. So if I go left or right 1 here, we're going to go up 1, or left, right 1, and then up 2. So there should be a point here and 1 here, right? Okay, what happens if I go left or right 2?
8.
8. How'd you get 8?
2 squared times 2.
So 2 squared is
4.
times 2?
8.
Good. Okay. To go right 2 up, 1, 2, 3, 4, 5, 6, 7, 8. Should be a point here, and left 2, 1, 2, 3, 4, 5, 6, 7, 8. Do you want me to check the work to see if I did it correctly? Do you want me to prove it to you? Now you got it?
Yeah.
You think you got it? Okay. You try your best drawing a straight graph. It's a lot easier on a paper. Okay, isn't this way so much faster?
Yes.
Yeah, way faster, right? Now, sometimes I might ask you on a test, what happens if my x is equal to 0? You have to figure out what the output is. You still have to plug it in. Sometimes I can do that on the test. No, what if x is 0, what's my answer going to be? What's my y? Nope. Plug it in. 0 squared is?
Oh, if x is 0, I thought you said if...
X is 0. Okay, what happens if y is 0? What are my answers? Nope. What are the zeros of the equation? If y is 0, what are the solutions?
Oh, no, 1 goes...
If this is y is 0, what are the two solutions that cross? They're called zeros or roots. What are the solutions here? Are you awake? I taught you this. And? Good, -2 and -4. Okay, these are basic things you should get, okay? -2 and -4. That's it. That's today's lesson, okay?